we've seen how to calculate the center of mass for the one-dimensional situation where we have discrete particles. What happens if we have 2 or 3 dimensions? So if we now have discrete particles on a plane or spread through space? Well, in that case, we can just consider each of the dimensions separately. So the coordinate for the center of mass in the x direction is still given by the same equation that xcom is equal to the sum of xi times mi over the sum of mi, where the sum of mi is the total mass of the system. And the center of mass in the y direction is given by a very similar formula. It's given by y center of mass is equal to the sum of yi mi over the sum of mi. And if we do have a z direction, then the center of mass in the z direction is equal to the sum of zi times mi over the sum of mi. So we just break the problem down, we consider each of the dimensions, and we can get the center of mass where it lies in each of those dimensions, and then we put it all together and we've got our coordinate for our center of mass. So let's have a look at an example of a problem that we can solve with this method now.
So the question is, 3 particles with mass m1 is equal to 1.0 kilograms, m2 is equal to 2.0 kilograms, and m3 is equal to 3.0 kilograms form an equilateral triangle with side lengths of 10 centimeters. Where is the center of mass of this system? Clearly show it on a diagram. Okay, so the first thing we're going to need to do to answer this question is to draw a nice clear diagram. So let's put mass 1 here. Here's mass 1. Mass 2 is here. And then mass 3 is up here. So these are along a horizontal line, as that will make the problem simpler for us. So we can choose where our origin is. We're not told where we have to take the origin as, but it'll be simple for us if we take the origin as the center of one of these particles. So let's take m1 as our origin. So we have x1 is equal to 0 and y1 is equal to 0, and the side lengths are 10 centimeters, and then this is 10 centimeters, and this one here is also 10 centimeters. So we've given the location of particle 1. For particle 2, we've got x2 is equal to 10 centimeters because it's 10 centimeters along the x direction from mass 1. And y2 is also equal to 0 centimeters as it's at the same height as mass 1. Now, calculating for particle 3 is a little bit more complicated. What we'll want to do is work out this height here. So this is y3, because this is our y-axis here, and this is our x-axis here. So in order to calculate y3, we're going to need to use a bit of trigonometry. For an equilateral triangle, all the angles are equal, so each of these angles here is 60 degrees. So we can say, well, tan of 60 is equal to opposite, which is equal to y3 over adjacent. Now, adjacent, that's x3. So this distance from here to here, that's x3. And this is entirely symmetric. So we've got that these two distances have to be equal. So x3 is equal to 5 centimeters. So going back to calculating y3 here, we've got tan 60 is equal to y3 over x3, and so y3 is equal to x3 tan 60, and so this is equal to 5 times tan 60, which when we solve on the calculator, we get 8.66 centimeters. So we have x3 is equal to 5 centimeters and y3 is equal to 8.66 centimeters. Okay, so now we have everything that we need in order to calculate the center of mass in the x direction and also in the y direction. So in the x direction, we've got x center of mass is equal to the sum of xi mi over the sum of mi. The sum of mi is equal to m1 plus m2 plus m3, which we can write as capital M, and it's equal to 1 plus 2 plus 3. So that is equal to 6 kilograms. Okay, so this is equal to x1 m1 plus x2 m2 plus x3 m3 all over the total mass m. Now x1, that was 0, so this is 0 plus x2, which was 10 centimeters, times mass 2, which was 2, plus x3, which was 5, times m3, which was 3, and that's divided by the total mass, which is 6. And so solving this, we get 5.83 centimeters. And then we do it for y, so y center of mass is equal to the sum of yi mi over the sum of mi. So this is equal to y1 m1 plus y2 m2 plus y3 m3 over m. And so y1 0, y2 is also 0, and y3 we calculated was 8.66 times m3, which is 3, all over 6. So solving this one, we get 4.33 centimeters, which is halfway up y3. So now to show this on our diagram, if that's our mass 1 there, let's change to yellow. Then we've got that the center of mass is halfway up the height, so it's there, and it's the x location is 5.83, so just over halfway along. So the center of mass is here on this diagram here.